Hi everybody, this is me again, Yousif Salih, chemistry teacher, and today we're going to have the second mini lecture in chemistry of grade 10. Let's start. Today we're going to talk about matter and its properties. Matter and its properties. So first, what is matter? Matter, the definition here is given. Matter, anything that has mass and volume, which means it has a mass, which means a weight. In some countries, they say weight instead of mass, such as UK. And volume, of course, volume here is the space occupied by the object or by body. So let's see what is the definition of mass. Mass is measurement of amount of matter in an object. Measurement of an amount of matter in an object. So it's clear that heavier object contains more matter, according to this definition. The heavier object contains more matter. Of course, the lighter object contains less matter. And we have a couple of examples here. For example, a sample of 2 kilogram wood, a sample of 2 kilogram wood contains more matter than a sample of 1 kilogram. These two samples are for one substance, or let's say one type of matter, which is wood. But the difference here in the mass of this is half as mass of the first sample. So amount of matter contained in the second sample is only half as contained in the first sample. And we have another example. So we have 1 kilogram of iron, 1 kilogram of iron, and 1 kilogram of wood. Because the mass is equal in both samples, certainly they will have the same amount of matter. They will have the same amount of matter. So the measurement of amount of matter in an object is the mass. Okay, this is about the first one, which is mass. Let's talk about the second, volume. What is volume? Volume is the amount of space that occupied by an object or a body in three-dimensional space. What does it mean, three-dimensional space? Which means it has length, width, and height. Length, width, and height. So this is volume. Of course, you have studied volume and mass in physics. Mass has a unit of kilogram in the international system, and volume has a unit of meter cube, also in international system. Of course, there are derived units you're going to study later for mass and volume. Now let's move forward. We have building blocks of matter. Building or basic building blocks of matter. Of course, matter are composed of very, very tiny particles, much smaller particles, each one called atom. Each one of them called what? Called atom. Okay, so the atom here, what does it mean, atom? Actually, atom is a Greek word that means indivisible, which means it cannot be divided to smaller. Despite this concept changed during 100 years later, but it's an old word in ancient Greek and means something that cannot be divided more. Of course, the term atom is said by ancient Greek philosophers. Okay, so someone called Democritus. Now let's have the definition, the current definition for atom. It is written here, atom is the smallest unit of element. I mean, smallest unit, smallest building unit. Smallest building unit of an element that maintains, that keeps, that shows. That maintains, which means that keeps what? The identity of the element, which means one atom of an element has the same identity of a sample of element much larger. Also, it keeps its properties, physical and chemical properties. So atom is what is smallest unit of element that maintains, that keeps, that shows the identity of this element. Okay, what is element? What is element? Actually, in chemistry, we divide the substances into pure substances into two types. One is element, the second is compound. Today we will have definition for both of them. So element is a pure substance that made up of one kind of atoms, which means all atoms are similar. So for example, we have this wedding ring. It's supposed to be pure silver. So all atoms in this ring are atoms of silver. All atoms are atoms of silver, which means they are identical in everything, identical in physical properties, identical in chemical properties, such as, for example, color, density, melting point, boiling point, and also chemical properties such as reactivity, for example. This is about atom. This is about element. Let's have an example. About an element. This is about carbon. Okay. This shows the deep structure of diamond. Diamond is what? Is a pure carbon. Diamond is pure carbon. Each red sphere here represents a carbon atom. Each red sphere in this structure represents what? A carbon atom. Actually, here is not very realistic because the sticks here are not present. They are attached to each other. The atoms are attached to each other in reality. But it's just for clarification. Now, we have more than 100 natural elements present in the periodic table. Of course, periodic table contains about 120, but some of them are man-made, and they don't present in nature. But in nature, we have more than 100 of them. Let's have another look on the diamond. Okay, diamond is a pure carbon form, which means a pure element in which the atoms all are identical. All are identical. So diamond, because it's pure element, pure carbon, all atoms here are similar in everything. Similar in everything. This is about element. Of course, we have, other than carbon, we have, we said more than 100 atoms. So the one example is the ring I told you, the silver ring I told you. What if the atoms were not identical? If the atoms were not identical, in this case, you're not talking about an element. You're talking about what? You're talking about compound. So what is compound? Okay. Compound, it's written here, a pure substance made up of more than one kind of atoms. More than one kind of atoms. Which means, for example, you have hydrogen and oxygen in water. In water, here, for example, we have H2O. Okay. H2O. H2O, water, is a compound. Why compound? Because the atoms are not identical. So we have a big atom of oxygen and two smaller atoms of hydrogen. So this is oxygen. These are hydrogen atoms. You see, the atoms are not identical. In the formula also it shows that we have hydrogen and oxygen. So water is not an element, water is a compound. Why? Because it is fit with the definition here, pure substance that made up of more than one kind of atoms. But the formula here the structure here is being repeated, which means we have many structures of H2O, each one called molecule. Now, let's have, this is a simple compound. Why simple compound? Because composed of only 3 atoms and we have 2 elements. So it is a simple compound. Let's have more complicated compound. We have an example about sucrose. Example of sucrose, and it has formula of C12H22O11. What does this mean? One molecule, one small particle of sucrose contains 12 atoms of carbon, 22 atoms of hydrogen, and 11 atoms of oxygen. So it's written composed of atoms of carbon, hydrogen, and oxygen. Let's see the figure. The figure here shows us that we have carbon atoms in green color, and we have oxygen atoms in red color, and we have in blue color hydrogen atoms. So this is a compound, and little bit complicated compound. We have more complicated than this also. But compared to water, it is complicated, and the molecule, it looks to be big. Why? Because simply it contains a lot of atoms. It contains a lot of atoms. This was about compound. We're going to study, of course, later more about compounds and the bonding inside the compounds, because the atoms here, for example, this hydrogen and this oxygen are bonded to each other. This carbon and this oxygen also bonded to each other. Later we'll study the bonds and types of the bonds. We have here a note. There are millions of compounds in nature, despite there are only about 100 or more than 100 elements in nature, pure elements, but the difference here in how they are bonded to each other. So as a result, we will have a wide variety of compounds. We have millions of compounds in nature, as well as the compounds that prepared by man, which means not present in nature. Now, let's go forward. Okay. Here something missing is properties actually. So let's get it more clear, but it looks to be erased. So we have actually here properties. Properties. Okay, properties and change of matter. As long as we have a huge number of compounds and elements, so we need to study the properties in order to distinguish between them, in order to differentiate them, in order to classify them. So to distinguish between substances, we need to know their properties. We need to know their properties. Okay, so the properties have been classified for more than one principle. The first principle is, are properties affected by amount of matter or not? So if the property is affected by amount of matter, which means depend on amount of matter, in this case we're talking about what? We're talking about, extensive properties. So extensive properties, properties that depend on amount of matter. How depend on amount of matter? We have volume. Of course, more water occupies more volume, or more oxygen occupies what? More volume. So volume is what? Volume here is an extensive property, an extensive. Also mass. Let's say a cubic centimeter gold cubic centimeter gold occupies, or it has about 19 grams of gold. But what if you have a breast ring of gold? Of course, it would have about maybe 15 grams or more. So mass also a property of matter that depends on amount of matter and changes when amount of matter increase or decrease. We have also amount of energy released or stored. We all eat carbohydrates, for example. Carbohydrates, more energy stored. Less carbohydrate, less energy stored. So it depends on how much carbohydrates you eat, you have. Energy released or even energy stored are also examples about what? About extensive properties. The opposite of extensive properties is what? Is the intensive properties. Intensive, not depending on what? Not depending on amount of matter. So for example, the color of this ring is silvery, or let's say gray, shiny gray. So if you have a larger sample of silver, it will have the same color. So color is what? Is an intensive property. Color is an intensive property because it doesn't change when amount of matter changes. We have density. Okay, density of water is about 1 gram per centimeter cube. It is the same if you have a bottle of water, or you have a gallon of water, or you have a tank of water, pure water, of course, I mean. It's the same density. Why? Because density is an intensive property that doesn't depend on what? That doesn't depend on amount of matter. Conductivity. Copper conducts electric current. Okay, a small piece of copper conducts electric current. A long wire of copper also conducts electric current. A cube of copper also conducts electric current. So conductivity doesn't depend on what? On amount of matter. That's why conductivity is an intensive property. Also reactivity. You might be not studying reactivity deeper, but reactivity means how elements or compounds or any substance undergoes chemical reaction. We have, for example, elements of group 1, lithium, sodium, potassium, they undergo reactions rapidly. So they are reactive. In the front, we have gold is totally unreactive. Platinum is totally unreactive. Also reactivity, a small piece of lithium reacts very rapidly with water. A big piece of lithium also reacts with water rapidly. A small piece of gold is unreactive. A big piece of gold also unreactive. So reactivity is a property that not depending on amount of matter. That's why we could say what? We say it is intensive property. In another classification, the properties are classified into physical and chemical properties. So let's talk about physical properties. Physical properties, what are physical properties? Let's have an example first and discuss it. So one of the physical properties is color. Okay, you can check the color of, for example, your coat without changing identity of the coat. Okay, the coat is made up of wool or cotton. When you knew that its color is black, for example, the identity of matter didn't change. Another one, when we measure the density of gold, we will say density of gold, it is written here, equals to 19.3 gram per centimeter cube. Okay, when you measure the mass and divide it on the volume and find the density of gold, identity of gold did not change. Identity of gold did not change when you measure it. Also, when you say, I have measured the boiling point of water, and the boiling point of water is 100 Celsius. when you measure it by a thermometer, did water changed into milk, for example, changed into acid, for example? Of course not. So these properties, the physical properties, are the properties that you can observe, you can measure without any change in identity. So we can see them, we can measure them, we can notice them without identity change. This is about physical properties. Let's see the physical change. Physical change, actually, most of physical changes are what are changes of state. What is change of state? Change from solid to liquid, from liquid to gas, opposite, from gas to liquid, from liquid to solid, and sometimes from solid directly into what? Into gas, called sublimation, of course, or from gas direct to solid and called deposition. All these changes that we said, we mentioned, the changes here only change in shape, which means also the identity is not included in this change. So let's have examples here about physical examples. Cutting a piece of wood here, even the state not changed. When you cut a piece of wood, you change the shape from one portion into smaller portions. So you change nothing. You change nothing. You just change the shape of the portions. Melting wax. Melting, just I want you to care about this. Melting is not burning. Burning is not a physical change, it's chemical. But melting, because it is only change of states, change from solid to liquid, it is a physical property. Also sublimation of iodine. We said sublimation directly from solid to what? To gas. From solid to gas. Iodine is iodine if it is solid or gas. Wax is wax if it is solid or liquid or even gas, despite it's a little bit hard to convert it to gas. So the changes here, it says most of physical changes are changes of state. Most of physical changes are changes of state. For example, we said liquid to solid, solid to liquid, liquid to gas, gas to liquid, solid to gas, gas to solid. In order to understand this better, of course, after we have the definition of change of state, it's change of a substance from one physical state to another physical state, as we said. But in order to have better understanding for the physical change, we need also to study the 4 physical states of matter. The 4 physical states of matter. The first one, which is the solid state. Of course, solid state has a definite shape. Also has that, a definite volume. So solid state is the state of matter in which the shape and volume are definite. Shape and volume are definite. The second one, liquid state, the volume is definite, but the shape is changing. So for example, the volume of the sample of water is about 150 milliliter or centimeter cube. But its shape is changing and it takes the shape of the container. It takes the shape of the container. When you put it in another container, it will change to the shape of the other container. So liquid is the state of matter in which shape is, shape is indefinite, but volume is definite. Let's have the third one, gas state. Both are changing, both are indefinite, the shape and the volume. Also, the shape, it takes the shape of the container, of course. So for example, the gas inside this room, inside this studio, takes the shape of the room, the walls of the room. Also for the volume also changed for the gas. When you press, it would reduce the volume. When you loosen the volume would increase. This is just like when you have a syringe in your hand and remove the needle, put your finger on the mouth of it and press and loosen. When you press, you increase the pressure, the volume decreases, and vice versa. When you loosen, the volume increases. So in gas state, we have actually both are changed, both are indefinite. So the shape and the volume are indefinite. The fourth one is a plasma state. Plasma state, not very familiar here on Earth. Why? Plasma state is the state of matter at very high temperature. When we say very high temperature, we don't mean 100 Celsius. We don't mean 500 Celsius. We mean thousands, maybe 10,000. So, and this temperature, very high temperature, the atoms lose most of their electrons. What would stay when it loses the electrons? On the nuclei. The nuclei, which means the protons and the neutrons. We will study them later. Plasma present in stars, including our own sun. So plasma state is the source of energy. Why? Because the stars are the source of energy. Our own sun is the source of our energy. And inside the sun and other stars, plasma present. So also there are, let's say, special cases in which plasma form. And lightning, the temperature gets very, very high. So also in lightning, plasma present. But it's for very short period of time. Okay, now let's go forward. Actually, it's written here. The most common state in the universe is a plasma. Why? Because all the stars composed of plasma, and we have billions and billions of stars. And the least common state, so see here the most common, just focus on this, the most common state is what? Is a plasma. And the least common state is what? Is liquid. Why this? We know that about 75% of the Earth's surface is covered by liquid, by water. So what is the least? Yes, it is the least. Why? Because the liquid presents in only a narrow range of temperature. So for example, water is liquid between 0 Celsius and 100 Celsius, but it is solid much lower until you get negative 273, the absolute zero. And whatever we heat, the water steam, it keeps as gas. So the gas and the solid have much wider range of temperature in which they present. Liquid only presents in a narrow range of temperature. That's why the least common state in the universe is what? Liquid. And the most common state in the universe is a plasma, because the plasma presents in very, very wide range of temperature, thousands, and go up. This was about the physical properties. So let's move to chemical properties. I don't want the mini lecture to be very long, because I don't want you to get bored. Okay, the chemical property. Chemical properties describes the ability, maybe the ability or disability, or also is able or not able to undergo a chemical change. So for example, when we say, okay, carbon is burnable, it can undergo burning. When you say oxygen assists in burning, it also participates in what? In burning. So in both cases, ability or disability, we can say here or disability, which means it doesn't. So for example, when we say gold is not reactive, gold is, and platinum is not reactive, which means we say the disability, we describe the disability. Also, it's ability or disability. So the disability of gold to undergo what? Oxidation. Under what? Under normal conditions. So here, the chemical property describes the substance's ability to undergo a chemical change. For example, oxygen assists in burning. Oxygen undergoes this reaction, and oxygen participates in the reaction. Lithium reacts rapidly with acids. Lithium can undergo this reaction rapidly. So it is a chemical property. Gold doesn't oxidize. It is disability. Doesn't oxidize under normal conditions. Under normal conditions. That's why gold keeps its value and keeps its purity. That's why gold is precious. Gold is expensive. Why? Because it doesn't change. This is about the chemical property. Let's go to chemical change. In chemical change, we have actually some details we need to take care about. So, for example, we have chemical change or chemical reaction. It's the same. The change in which one or more. The change. Okay, we have the change. Sorry. It's the change in which one or more substance change to different substance or substances, which means the identity changed, the physical properties changed, the chemical properties changed, all are changed. In this case, we can say it's a chemical change or a chemical reaction. We have an example here. We have solid mercury or mercury 2 oxide, because charge of mercury here is positive 2. We can say oxidation state 2. By heating, we have here heating. The delta here means heating. This solid mercury oxide is being decomposed into liquid mercury and oxygen. Of course, we had here a compound and we got two pure elements. The properties, all properties of the products here of the liquid mercury and the gaseous oxygen differ very widely from the properties of mercury oxide. So, in this reaction, the products are new substances. Okay, any chemical reaction involves reactants and the products. Here we have the reactants here, the products here. The reactants are substances that undergo a chemical change, that participate in a chemical change. And the products are substances that form as a result of chemical change or chemical reaction. So, what are the reactants and the products in this reaction? These are mercury and oxygen. Definitions of reactants and products are written here. Let's go forward. In previous reaction, say mercury and oxygen are what? Are products, because they formed as a result of this reaction. We have couple laws related to physical and chemical change. Actually, we have law of mass conservation. What does mean mass conservation? If we get back to the reaction here, if we measure the mass of mercury and oxygen that produce, it equals the mass of mercury oxide. So the mass is conserved, the mass maintained, the mass kept, the mass preserved. So no change in mass. The total mass of products equals always the total mass of reactants. This is law number 1. The law number 2, it is law of energy conservation. In any chemical or physical change, energy is not created nor destroyed. So what happens? It changes from a form to another form. For example, we eat bread. The chemical energy stored in bread, We change this energy into what? Into thermal energy, into heat. And we make our activities. The car burns fuel and changes the chemical energy in a fuel into what? Into thermal energy, later into what? Into mechanical energy. During any change, physical or chemical, the mass and the energy are not created nor wasted, not destroyed, but they change from a shape to another shape, from a form to another form. These laws, what we call law of mass conservation and law of energy conservation. Energy has many forms, such as we have heat energy, electric energy, mechanical energy, potential energy, chemical energy, light energy, and a lot of them. This is all about today's mini lecture. I wish you get the benefit from it. In case you have any questions, you can contact with the people responsible to this website, and have a nice day.